Hello everyone. In this video we're going to talk about chapter 5 on sensation and perception, and we're going to talk about vision and hearing in this video. But first of all, we're going to talk about why do we care about sensation and perception in psychology. Seems like sensation is really a physical process. It's kind of an anatomy sort of a deal, and why are we concerned about that in psychology? And really one of the things we're interested in psychology is perception. Why is it that one person can see the same thing and still describe it differently, see it differently? Why is it that some people like really spicy food and other people do not? How can somebody hear one thing and another person hear something completely different? So we're really more interested in perception in psychology, but we really need to understand how our senses work in order to understand how perception works as well. I put this black and white picture up here to talk a little bit about this idea of what we pay attention to has a lot to do with what we see, right? If we look at just the white portions of that picture, we see things that look kind of like chess pieces or vases. If we look at the black portion of that picture, we see people, and they look like kind of Roman people in robes and stuff. So it really depends on what you focus on, has a lot to do with what you see, and what we focus on has a lot to do with what we're interested in, what we like, what we don't like. So that's really more why we're interested in this kind of information in psychology. So the definition of sensation is just information coming in from our senses. So our sense of vision, our sense of hearing, our sense of smell, our sense of touch, and I forgot to, taste should be on here as well, because taste is definitely a sensation. But sensations are physical processes, whereas perception is really a psychological process. So perception is how our brain processes and perceives information coming in from our senses. How does it interpret and assign meaning to whatever it is that we're seeing or hearing or feeling or smelling or whatever? And it's really based on our past experiences. We smell chocolate chip cookies. That brings up lots of memories, lots of ideas about chocolate chip cookies, whether we like them or don't like them. And so our perception has to do with our past experiences, also with our expectations. We sort of expect like chocolate to taste a certain way. And if you've ever had dark chocolate or unsweetened chocolate, you know how terrible that can taste. But it looks like regular chocolate, so it definitely changes our expectations are one thing, and then when we actually taste it, it's really different. So perception is a psychological process, and that's more what we're interested in. But we really want to understand, how does information from our senses get to our brain and then get processed? So that process is called transduction. So our senses take in information and then convert that information into electrical signals that the brain can actually understand. And that process is called transduction. So visual transduction, we see something and our eye processes that information, converts that information into neurological signals that our brain can understand. And I put this eyeball up here because this is the frontal part of the brain, and our eyes take in this information and send the information to the back of our brain, which is our occipital lobe or our visual lobe there. And then our visual lobe processes this information, but other parts of the brain also process this information. So visually, we see a butterfly, but our brain also thinks about all the other things that we know about butterflies, right? And also looks at all the other possibilities of what this butterfly could be. Could look like a moth, it could look like a firefly, could be like a bird because it's flying. So we sort of think about all the other things that might be related to butterflies as well. And then we think about memories. This monarch butterfly here brings back memories to me of when I was a little kid and I wrote a little report about monarch butterflies. So our brain has all this really that random information stored in there, and everybody's got different random information stored, right, about different things. So that's how we see things differently. We process information based on what we already know, what we've experienced, and everybody has different experiences. So how does our visual system actually work? So we all know what our eyes look like. We know that the colored part of our eye is called the iris, and the little black dot in the middle of our eye is the pupil. And the pupil is designed to monitor how much light is going into, or control how much light is going into the eye. So during the day when the light is really bright, our pupils are really small to not let too much light in. And then as it gets darker outside, or if we're in a darker room, those pupils get larger to let in more light so we can see better. The lens that's right behind the eye here actually focuses the information that we're seeing onto the back of the eye, where the retina is and the fovea is. So inside the retina are rods, and rods are individual cells that actually process the visual information that we're seeing, and they detect black and white images, whereas the cones, they're located in the fovea, and they actually detect color and detail. So both the rods and the cones actually convert that visual information into a neurological signal that then gets sent to the brain and processed by the brain. And if you look here, the eyes take in this information, process this information, and it sends the information down the optic nerve through this optic chiasm down to the occipital lobe. And if you notice, the right eye actually gets processed in the left side of the brain, and the left eye, the information from that actually gets processed in the right side of the brain. And then once that information is received by the brain, that's where perception occurs and where our brain decides what it is we're actually seeing. So that's how our visual system works. And there are people that have different problems with their visual system. There's all sorts of visual impairments where people can just see, peripherally, they can only see the sides of their vision. There are people that can only see a little box of vision. There's lots of different things that can happen with vision. And of course, as we get older, a lot of times our vision deteriorates, and some people just, have to wear glasses from an early age because part of their lens isn't working correctly. And then there are also people who are colorblind, and that's because their color cones are not working correctly. And a lot of times when we think of somebody being colorblind, we think they go around seeing the world like a black and white TV show, but that's not the case. In fact, black and white color blindness is really, really rare, and usually it's related to other visual problems as well. So people that are colorblind have perfectly good vision, they just don't see particular colors. And the most common is red-green color blindness. And this image down here is an image of what a normal person would see. Should probably use that term normal, but where somebody that's not colorblind would see this color. And somebody that has red-green color blindness would see this image like this. And that's the most common form of color blindness. And color blindness is mostly found in men. And the reason for this is because it's found on the X chromosome. So if you remember from chapter 3, men have an X chromosome and a Y chromosome. So if they inherit the trait for color blindness on their X chromosome, they don't have any way to compensate for it. They have color blindness. Women, on the other hand, have 2 X chromosomes, so if they inherit that trait for color blindness, usually that other X chromosome does not have that trait, and their vision will operate off of that good chromosome. These little circles that are on here that look kind of like blobs that have numbers, kind of faint looking numbers inside of them, are actually a test for color blindness. So you should be able to see faint numbers in there. Somebody with red-green color blindness would have a lot of difficulty seeing those numbers. It would just look kind of like a blur to them. So color blindness is a really common thing. So what about how do we actually perceive things? We don't just perceive things just through our visual system or just through our hearing system, right? We take information in from all of our senses all at the same time, right? So this image talks a little bit about seeing a coffee pot. So we're taking in what that coffee pot looks like. We're taking in how that coffee smells. We might hear the sound of that coffee brewing. So that's, and we also are basing that on our knowledge of coffee and coffee pots, which could be really vast or it could be pretty limited depending on if you like coffee or not. So all sorts of information is taken in from different sensory receptors, converted to neural impulses, and then it's perceived and or interpreted based on what we know already. And I put this funny looking espresso machine in here because for some people, this might be a foreign object. They might not know what this is. It doesn't necessarily look like a coffee pot, so it might take them much longer to determine what that is. So what we perceive has a lot to do with what we're familiar with, what we've seen a lot of, and how quickly we're able to identify what we're seeing has a lot to do with our experiences, right? So if we love espresso and we've seen a lot of espresso machines, we'll pretty quickly know what that is. So how does our hearing system work, and how does auditory transduction work? So how do sounds get translated into neural signals that our brain can understand and that we can actually process and identify? So first of all, sounds come in through our outer ear. And the reason our ears are shaped kind of funny like this is that it concentrates that sound into our ear canal. And once that sound comes into our ear canal, it causes our tympanic membrane, or our eardrum that we know of more likely, to vibrate. So the tympanic membrane, or the eardrum, is kind of like a trampoline. It just moves around a lot. And when sound comes in, that's what it does. And it causes the little bones that are inside of our inner ear to start to vibrate. And then those little bones actually cause the fluid that's in this little snail-like thing to move, and that's how sound actually gets processed. So this is an image of what it looks like inside this cochlea, or this snail-like thing. And it's kind of an idealized image. These look like little eyelashes in here, but there are little hair cells inside the cochlea here. And as the fluid moves inside the cochlea, because of the sounds that are coming in, these hairs actually move. And the pitch theory of perception, of reception or hearing perception, says that the way these little hairs bend, and which hairs actually bend when these fluids move around, is what sends a signal to our brain about what sound we're hearing and what the pitch of that particular sound is hearing. So it's a combination of these hairs moving around that actually send information to our temporal lobes right above our ears here, and actually that's where the sound actually gets processed and identified. So this place theory of perception is really interesting, or reception I put on there. So when we receive sounds, those sounds cause those little hairs inside the cochlea to move, and that's what sends the signals to our brain about what we're hearing. Part of the reason that we know this is that when people have hearing loss, oftentimes these little hairs are damaged in the area of hearing loss where they aren't able to hear those particular sounds. One of the more common ones was called hunter's notch, still is called hunter's notch, and people that hunt a lot or shoot guns a lot has a very loud sound to it, and if they don't wear earplugs and aren't cautious about their hearing, what happens is they lose the little hairs in a particular range of that sound, and they can no longer hear that sound anymore. And once these hairs are damaged, they can't be replaced. So that's one form of hearing loss that's actually somewhat preventable. Today, people do wear hearing earplugs and are much more protective and concerned about their hearing. Rock stars and people that work in factories, construction workers that are exposed to really loud sounds are often required to wear earplugs because it protects that eardrum, protects those keeps those vibrations from getting so intense that they cause damage to your hearing. And because once you have this kind of a hearing loss, it's not repairable. And certainly as we get older, these little hairs wear out. Other parts of the hearing system can also wear out. Our eardrum can wear out. Some of these little bones can start to wear out. And so often as you age, your hearing goes, your vision goes. It's not as sharp as it was when you were younger because it gets worn out after being used a lot. So that's how our hearing system actually translates that information from information coming in from our senses to neurological signals that get sent to the brain and interpreted. I put this information on the cochlear implant here because there are infants that are born without a cochlea and they have severe deafness or severe hearing loss. They're unable to hear anything. And I don't know how long ago the cochlear implant was developed, but it's been around, I would say, 10, 20 years or so. And it's pretty amazing. It can actually replace that cochlea in the brain and allow the infant to actually be able to hear. This is what the cochlear implant looks like, and it looks kind of like it's painful, but it's actually not. This is actually held on by a magnet that is surgically implanted under the skin, but that cochlear implant is easy to take on and off for baths and sleeping and comfort and things like that. But one of the interesting things about cochlear implants is that it has to be done at a certain age range, really before 18 months or so, because the brain needs to be able to develop that ability to really perceive sound and understand sound, also the ability to perceive language and understand language. So if a child receives a cochlear implant, say at 5 or 10 years old, their ability to hear actually is problematic because their brain has never heard sound before, never processed that sound before, never gotten that neurological signal before, doesn't know how to interpret that neurological symbol. So when a child is born without a cochlea, with hearing loss, parents have to decide really quickly to have this surgery and to have this cochlear implant, because otherwise the child won't be able to interpret the sounds that they hear. And there's a little bit of controversy about this in the deaf community, because many deaf people feel like they're able to live a full life without being able to hear. But most parents really want their child to have every experience in life, and if this is something they can provide for them, I think it's worthwhile. And it's certainly not a negative commentary on people who are deaf, because people who are deaf definitely can live a full life and communicate through sign language, and that's not the concern. But they're missing out on music and sounds and lots of other things in life that I think, if as a parent, I would want my child to be able to have that. So just a little bit of information on cochlear implants, and that's it on vision and hearing. I'll see you in the next video.